All right, for this next one, number 4, we have that 3 towns, A, B, and C, are represented as coordinates on a map where x and y axis represent the distances east and north of an origin. Okay, that is why we have this north symbol over here, and technically we should have an east symbol over there. Okay, so that would be my x, that would be my y. That is what it's telling me. Blah, blah, blah. Our units are kilometers. Units are important. We're going to leave that highlighted. Town A is located at negative 6,1. That is this here. Town B is located at 8,6. That is this here. And we have a road that runs along the perpendicular bisector of AB. This information is shown in the following diagram. Perfect. All right, so before we jump into part A and part B, what the fuck is a perpendicular bisector? All right, so let's start with a couple, a couple hints. See? First things first, the word perpendicular should be ringing a bell, okay? You have two types of lines, all right? You're gonna have parallel, you're gonna have perpendicular. I mean, these are the type of lines we should like really care about, okay? So perpendicular, or actually no, let's go with parallel first, because I think it's a little more friendly. So parallel lines look something like this. Okay, what is cool about parallel lines? Not that you have to be a nerd to find it cool, but what is cool about parallel lines? That they have the same something. They have the same slope. So parallel lines have the same slope. All right, a perpendicular line, which I'm going to draw down here in red, looks something like this. Okay, clearly the slope isn't the same there. Also, perpendicular can look like that. All right, so don't flip out if you ever encounter something like that. The thing about perpendicular lines is that they have like, it's not really an inverted slope. It's a reciprocal slope. I'm going to explain reciprocal in a second, okay? And so parallel lines have the same slope, so they never touch. You can describe it like this. And perpendicular lines make 90-degree angles where they intersect, okay? So that's just a couple more nerd comments coming your way. A reciprocal slope looks like this. If, let's say, this line here, okay, has an angle of, a slope of, say, 1/2, that means that the perpendicular line to that, okay, its slope is going to be -2. That is reciprocal. Okay, how did I reach -2? So I take 1/2, I do the reciprocal of it. Okay, so first of all, I first flip it, and then you multiply by a negative. So I flip it, so it's 2/1, and then I do the negative, -2/1, which is just -2. Okay, let's make one more example. So for the reciprocal, you sort of flip it and then times it by a -1. Um, let's say one of my slopes is -3/4, and I tell you this is the angle of line 1, line 2 is perpendicular to it. What is the slope? Well, first you flip it, ¿cierto? First I flip it, so it's going to be -4/3, and then I do the negative, see? Then I do the negative, I end up with 4/3, see? Because negative times negative gives me positive. Okay, so that's just a little bit of an idea for what the heck reciprocal slope is, see? If you want to get really fancy about it, if you know that you have perpendicular lines, then what you can do is say that your first slope times your second slope will always have to equal -1, see? So if you want to remember like a more mathy way to go about it, it's this. Intuitively, it's this. Okay? Cool. So keeping that in mind, that is what perpendicular is about. Now, what the hell is bisector? Okay, so bisector following its name with bi, we're talking about two, ¿cierto? All right, so And sector, you know, and this sounds a little bit like the word dissect, okay? So when you dissect something, you're opening it up, stuff like that, etc. If you bisect something, you are cutting it in half. Ooh, what did I say? Cutting it in half. What is that telling me? So this road, C, okay? I mean, no, not C, sorry. So this road, okay, is this guy here. And so what that road is doing is that is the perpendicular bisector of AB. AB, I'm going to put in pink. Okay, so AB goes like that. Now, since the road is the perpendicular bisector, that means that, first of all, the slope of this is going to be the reciprocal of this one. Okay? And second of all, since it's the perpendicular bisector, that means that this distance is equal to this distance. So if this distance is 3, that means this distance is 3. Okay, so there's two things going on. That it? And after this, we will jump into part A and part B. I just think it's important to leave all of this defined first, okay? Perpendicular bisector shows up quite a bit, and those words scare a lot of people. That it? So on one side, we have the perpendicular thing, which makes you flip slopes and put a negative on it. And on the other side, we have the bisector, which gives us the information that this half is equal to this half in terms of distance. All right? Cool. So now that we understand the vocabulary and what's going on and all that good stuff, let's jump into it. Part A. Find the equation of the line that the road follows. All right, cool. So since we know that it's a perpendicular bisector, we need to capitalize on that information. See? So what I can do for now is get the slope of the guy in pink. Okay? So the guy in pink, how can I work around it? Well, the slope formula, which is in your formula booklet, is over here. So I'm gonna go ahead. Oh, slope doesn't show up. Gradient maybe? Gradient. Okay, so, aha. I'm glad that happened so I can show you something. Gradient is the same shit as slope. Okay, they are synonyms. So gradient equals slope. This is my gradient or slope formula. I'm gonna write it down over here. See? It is m equals y2 minus y1 divided by x2 minus x1. Now, some of you have probably heard, I know that slope is rise over run. See, this is a very common way to teach it. It's rise over run, and everyone memorizes it this way. And you know, they do like this thing, and then they count this way, and then that's rise over run. Okay, sure, correct. Whatever floats your boat. Notice the following. This y, if we think of an axis, ¿cierto? This y is up here, and y is for vertical. See, y is my vertical line. And so it makes sense that anything rising has to do with my y values. See? So that is why my y values are on top. The rise is just going to be y2 minus y1. See? The run is just going to be x2 minus x1. See? Because my x is going to be my horizontal, or where it's going to be running. See? And here's my rise. And so they're just a little bit of a intuition sort of thing. If you ever forget the slope formula, but you remember the rise over run, you can recall that, okay, so if it's rise over run, my y values have to be on top. Therefore, my x values are on the bottom. See? So they're just a little bit of intuition why that formula is the way that it is. Let's move on. All right, so I have my slope. See? Or let's say I have my slope formula. y2 minus y1 divided by x2 minus x1. And I have my 2 points. See? I'm talking about the ones in pink. And so a lot of people here can kind of get tripped up on like, what is my x2, what is my x1, how do I define that, blah, blah, blah. Right now I have 2 points. All right, so now let's go ahead and define which are my 2 points that I have. So on one side I have point A. Actually, I'm going to do it down here. So on one side I have my point A, which is -6, comma, -1. And on the other side I have my point B, which is 8, comma, 6. All right, so a common mistake that people do here is that they get mixed up on what is x1, what is x2, what is y1, what is y2. And so x1, y1, x2, y2, x3, y3, all make reference to a set of points. Okay, so you always have sets of points here, see? And you need to be consistent. So x1 has to go with y1, x2 has to go with y2, x3 has to go with y3. You cannot have a point that is x1, y2. Okay, that is illegal. That we do not do that. Okay, that is illegal. These two are correct. These three are correct. Why is this one illegal? Because this one does not go in line with this two. Okay, so you really gotta be careful, and I strongly suggest you write out your points and are just very, slow about it. See, there's no reason to make a mistake here. Just take your time, write down the points, which is what I just did with A and B, and define x1, define x2, define y1, define y2. So I'm gonna do that now. X1 is gonna be -6. Y1 is gonna be -1. X2 is gonna be 8. Y2 is gonna be 6. Okay, that's a small step, but it can actually get you very far. So y2 is 6 minus y1 is -1. Whenever I plug in a negative, I strongly suggest you put it in parentheses. Okay, just a rule of thumb. That way it's less likely that you mess up a double negative. On the bottom, I have x2, which is 8, minus x1, which is -6. So I do plug it in plug in parentheses again. So up top, I have double negative. That makes 6 plus 1. If you ever have trouble remembering that double negatives make a positive, okay, here is a trick that I like to use. So we're gonna say that we're gonna say that negative is going to be, hate, all right? And we're gonna say that positive is going to be love. And so, if I have, let me just copy this real quick. If I have a negative and then a positive, see? And I read it out loud, this says, if I hate to love, I'm a hater. So it's negative. If I love to hate, if I love to hate, what am I? A hater or a lover? If I love to hate, I am a hater. If I love to love, am I a hater or a lover? I'm a lover. And if I hate to hate, then that makes me a if I hate to hate, I'm a lover. See? Alright, whatever. Here's a little bit of a pattern to remember the negatives and positives and whatever. I just mentioned it because I know some people have trouble with it. Might as well put it out there, see? So up top, it's double negative. You hate to hate, you're a lover. On the bottom, we have the same thing, double negative. You hate to hate, you're a lover. So it's going to be 6 plus 1 divided by 8 plus 6. What does that give me? It gives me 7 over 14. I can simplify this a little bit. I end up with 1/2. All right, so what is this 1/2? Why were we doing this? We were doing this for the gradient formula. Okay, and that gave me the slope. It gave me the slope of what? It gave me the slope of AB. So M1 is going to be M1 is going to be 1/2. All right. I'm just going to call this my line 1. Okay, the thing in pink is going to be line 1. That is my slope. See? So, what does that tell me about line 2, which is going to be in blue? Okay, what does that tell me about line 2? The road. See, road is going to be L2. What does that tell me about the slope of L2? Well, L2 is the perpendicular bisector to L1. So the perpendicular part tells me that I need to flip it and do a negative. See? So M2 is going to be my slope of L1 flipped and then, multiplied by a negative. See? So first I'm going to flip it and then I will do the -1. That means my slope is -2. So M2 is -2. All right, so for the equation of the line that the route follows, which is for L2, I already have the slope. See? Um, all right, there's a couple of ways for finding a, how do I say it? The equation of a line. See? The one that I think is the best, which I think is in your formula booklet. Do I have what I need? Distance. Sorry, give me 1 second. Whoops, not my Instagram. Ah, it was in front of me the whole time. Okay, so I am trying to find the equation of a straight line. See? Which is exactly right here. And so I have three options. I can either use this guy in the middle, or this guy on the right side. See? All right, there's a couple of things going on with each. The one that I almost always use for finding a new equation, see, so I strongly suggest you stick to this, is this guy here. All right, this guy is called the point slope formula. All you need to make it work is two things. You need the slope and you need a set of points. So if you have the slope and a set of points, you're good to go. See? So coming back to what I have over here, I do have the slope. See? Awesome. Do I have the set of points? Not yet. How can I get it? All right, so I know that this road cuts through the pink line. See? So I know that this point here is in both equations. All right, so now that I'm trying to find this point here, see? I need to use all the information I can. So first of all, it goes through both lines. It goes through L1 and L2. See? The other thing I know is that L2 is a perpendicular bisector to L1. So remembering the bisector thing, it is cutting it in half. See, so the distance here is equal to the distance here. All right, so that is actually a bigger hint than what we think. Because what I can do is that I can look at my change in X and my change in Y, find halfway through both, and I'm good to go. What do I mean by this? If I were to put this on a grid line, okay, and make it a little more pretty. All right, so I know that I'm first going to put point A. All right, so I know that point A is 1, 2, 3, 4, 5, 6, -6, comma, -1. See, so this is point A. On another side, I have point B, which is at 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. It's going to be around here. All right. Point B. Okay, I know it's not drawn to scale. I know it's not pretty, but it will make a very good illustration of my point. And so what is the halfway from A to B for my X values? Ah, for my X values. So if I'm only comparing my X values, and here I have -6 for my X values, and here I have positive 8, comma 6. So if I analyze only my X values, I'm going to be taking this guy here and this guy here. So if I make a number line and I put this -6 here and this 8 way over there, and I put everything in between, I'm going to see that I have -5, -4, -3, -2, -1, 0. Okay, so here I'm going to put 0. 1, 2, 3, 4, 5, 6, 7, 8. See? And so if I ask you to find the halfway point now, it's going to be so much easier. See? And so what I like to do is that I jump once here, I jump once there. I jump once here, I jump once there. So over on this left side, I am now on -5, -4, -3. Over here, I am on 7, 6, 5. See? -2, 4, -1, 3, 0, 1. And now if I were to do this like one more time, they will both meet over here at 1. So what does that tell me? That my middle point for my x values is going to be 1. So this point here, I know has an x value of 1. 1 comma something, see? For the other one, we can do the same thing, see? So we're going to go ahead and do a number line comparing -1 and 6. So go ahead and do a number line. Here I have -1. Here I have +6, see? I'm going to do this one a little more detailed because I think the last example maybe wasn't so clear. This is going to be 0. This is going to be 1. This is going to be 2, 3, 4, 5, and 6. So what is the middle point? Well, I'm going to jump once here, jump once there. Jump once here, jump once there. Jump once here, jump once there. And so now, since it's, they're like facing each other, that means that my middle point is actually going to be right here. So that is my middle point, see? If they both jump one more time to meet in the middle, it would be 2.5. All right, anyways, there's a lot of different ways to do this. I think the number line thing is super useful. You can also do the number line thinking about it like this, see? So you could count this way. So here it would be for my x values. And you can also jump for your y values like this, see? Jump like that, compare with this, see? Again, there's a lot of different ways. I'm just showing the one that I think is the most intuitive, to each their own. Got it? So here it's going to be 2.5. Over here we said it was 1. So that means my x value is 1. My y value is 2.5. All right, so now I have the slope and the set of points. That means I can apply the point slope formula, which looked like this. See, we had y minus y1 equals mx minus x1. All right, so what is my y1? 2.5. What is my m? -2, ¿cierto? -2 from before. X minus x1, which we said was 1. See, this one here. All right, cool. So if I go ahead and solve this, then -2.5 stays on the left. This -2 is going to distribute, so I'm going to end up with -2x plus 2. I throw the 2.5 on the other side. I end up with y equals -2x plus 4.5. All right, and that is pretty much for part A. That would be part A. Later on for part B, they tell us that town C is due north of town A and passes through town C. Find the y-coordinate of town C. And so what we need to identify here, see, is what we know about point C. So we know that point C cuts through L2, okay? So that means I can use this guy here. Okay, that is my L2. It's what I found in part A. Got it? So I can use that guy there. See? And what else do we know about point C is that it is due north of town A. Now this detail here, although it seems small, is super important. Okay, because it is due north of town A, you can assume it is due exactly north of town A. What does that mean? Since it is due only north, that means my east or west remains unchanged. And so what is my east or west of point A? It is -6. So I know that point C is -6, comma something. Once I find that something, I will have all of part B. All right, cool. So I'm gonna go ahead and plug in -6. I'm kind of running out of space, but I think I can do it up here. See? So I'm gonna plug in -6 into this equation. I end up with y equals -2. Whoops, sorry. Y equals -2 times -6 plus 4.5. So y equals 12 plus 4.5. Y equals 16.5. So that means that my point C is going to be -6, comma, that is a 6, -6, comma 16.5. So that would be my point C. That would be for part B. And that is number 4. I think it's important to highlight two things here. First of all, fucking perpendicular bisector. I know it's weird, but it's more intuitive than what you think, okay? The perpendicular part makes reference to slope, okay? And the bisector part makes reference to a same distance cutting in half, see? The other thing that's important to point out is that part B needed part A, all right? And that is a pattern you can notice in a lot of IB questions, not just in math. Part B, you needed something from part A. Okay, so if you were in part B and you were thinking, damn, I don't know what the fuck to do, think about what you did in part A. It just might help you, and in this case, it was key. Because for part B, we needed the equation we found in part A. Consider that, and yeah, that is number 4.